Is sending 2 new missions to examine Venus. Venus is the second planet from the Sun and the hottest in our solar system, with a surface temperature of 500 degrees Celsius, high enough to melt lead. The missions are due to launch between 2028 and 2030. To discuss them, I'm joined by Professor David Block, an astronomer from Wits University. David, I'm very pleased to have you. I believe you've just popped out of a blackout, so it's good to have you on our TV screens. Tell us a little bit more about these missions to Venus. What are they hoping to get?
Well, indeed, I emerged from a black hole for a couple of hours in this freezing cold, but I've survived.
Oh, good.
It's very exciting, of course. You know, every time you go out of an evening, you often see that brilliant, blazing star-like object, which is, of course, the planet Venus, known as the evening star and sometimes the morning star. Venus has captivated the imagination of mankind for many centuries. Venus is a very seething world, almost like a greenhouse. In fact, you have clouds of carbon dioxide, and then mixed with the carbon dioxide comes down rain of sulfuric acid. So it's a very, very strange world. Also, Venus does not rotate like the Earth does. The sun on Venus would rise in the west and set in the east, contrary to on Earth, where the sun rises in the east and sets in the west. Venus, interestingly enough, even though it is so hot, as you've correctly said, Jane, 500 degrees centigrade, hot enough to melt lead, Venus does have continents, you know. The northern continent is called Ishtar Terra, after Ishtar, the Babylonian goddess of love. And that is about, I would say, the size of Australia. That's the northern continent on Venus. And then the southern continent is called Aphrodite Terra, after the Greek goddess of love. And that's roughly the size of South America. So that much we know. But the point is, Venus is completely covered in cloud. So you cannot really see the surface. And I think that's what makes these 2 probes so exciting, which will be heading towards Venus in due course, is that we hope to learn a lot more, not only about the surface terrain, which is extremely interesting because Venus oozes with multitudes of volcanoes, and there are huge plains. In fact, 80% of the Venusian surface is covered by smooth volcanic plains. So there's a lot of activity, but there's a lot of mystery because you cannot see through the clouds. You have to actually go there and send spacecraft to do all the imaging and sensing for you. And hopefully, of course, it's a while away, but the point is that I think it's a great first step for NASA, as it were, in this epoch, to send a spacecraft to Venus to try and unlock these mysteries. You know, as I say, not only what does the surface look like, we know there are 2 continents, but what do the volcanoes look like? How frequent is the volcanic activity? Imaging through the clouds should be spectacular because you've got these thick clouds of carbon dioxide and then sulfuric acid and other elements such as ferric chloride and so forth. So it's
let me just jump in here, David, if I may. I mean, it's obviously massively exciting. I'm just wondering, and you know, it's great to see that NASA, after time of being idle a couple of years ago, is really getting its act together. How challenging a trip will this be? I mean, how long will it take? What's needed to pierce through that cloud and get to see what we need to see?
Yes, you know, technology today is so far advanced that the trip should not take too long, and to do the imaging will be very routine. Do remember this, that we've sent I mean, I've taught my students how to send spacecraft to Jupiter, to Saturn, to Mars. Now, for Mars, of course, you're looking at, several months. Here would be a reduced travel time. The technology is already, I mean, in terms of these two probes, the Da Vinci Plus, the spectroscopy, the spectrometers on board, everything would be set to go. Of course, the instruments still have to be all built. The spacecraft has to still be built. But the point is the technology, we really are, I think this is what's so exciting, and for me to see as a professor of astronomy, is that we are able, I mean, to give you an idea, Jane, I can study cosmic dust, the stuff of which you and I are made, at a distance of over 10 to 12 billion light years without any degree of difficulty whatsoever. So I should imagine it just depends on exactly what path, when NASA decides to send the actual spacecraft up. I don't have those details yet because the spacecraft has not yet been built. But it should not be too long. It depends exactly where the Earth and Venus are when they actually send it up. But as far as the imaging is concerned, of course, it will never actually enter the Venusian atmosphere because of the extremely high temperatures. All details to date indicate that it will be doing the investigations from above the cloud layer. But remember this, that, I mean,
David, I'm sorry, we're going to have to leave it there. David Brock, thank you for sharing your expertise with us, and enjoy the rest of your Friday evening. Thank you.